Okay, example problem number 4. A 2,575 kilogram van runs into the back of an 825 kilogram compact car at rest. They move off together at 8.5 meters per second, assuming no friction with the ground. Find the initial speed of the van, which is that one. Alright, so we're going to write this off as we have our conservation of momentum equation, m1 v1I plus m2 v2I equals m1 v1f plus m2 v2f. So the momentum of the van plus the momentum of the car equals the momentum of the van plus the momentum of the car afterwards. Now in this situation, the car has initial velocity of 0, so its initial momentum is nothing. And then they move off together, so they go off in the same direction and they're stuck together. So that means the velocity here and the velocity here are the same. So I'm going to do some mathematical trickery here, and I'm going to factor those out. Okay, so that gives me m1 plus m2, so the combined mass of both of them stuck together, times my final velocity. That's my total momentum after the equation. And before the collision, my total momentum is the mass of the van times the velocity of the van beforehand. Since this guy is 0, the total momentum before is just the momentum of the van. So if I'm solving for the initial speed of the van, I'm going to divide both sides by m1, like so. Those cancel, so my equation is my initial velocity of the van is m1 plus m2 times vf, all divided by m1. Alright, well, m1 is 2,575 kilograms plus 825 kilogram car, and their final velocity is 8.5 meters per second, and I divide that by 2,575 kilograms to get my V1I. So, calculator time. I have 2,575 plus 825 equals 3,400 times 8.5 equals 28,900 divided by 2,575 equals V1I is 11.22 meters per second. Awesome.